Okay, everybody, today we're going to be doing graphing proportional relationships, practicing problem solving. I'm going to start with number 8, so I guess I got the evens tonight. It says, for each graph shown, tell whether it shows a proportional relationship and explain the reasoning. Well, as I stated in class, for something to be proportional, it has to go through the origin and it has to be straight. It's not exactly straight, is it? Let's see. I guess if I was going to put straight, I should put a straight line. All right? If it doesn't go through the origin and it's not straight, it is not proportional. All right? So let's take a look at these. The first one has our line going through the origin and straight, so this one is definitely proportional. Okay? And if I was to explain my reasoning, it would be because it's straight and goes through the origin. All right? For B, we see that it does go through the origin, but the line is not straight. So it is not proportional. I'm just going to type this one out, make it a little easier on me. Not proportional goes through origin but not straight. All right, and let's go to C. This one is straight, but it doesn't go through the origin. So again, it is not proportional. Not proportional. Let's see, straight. Line is straight, but does not go through the origin. Okay, and let's move on to our next one now. You guys got 9, so I've got 10. Does the graph show a proportional relationship? If so, use the graph to find the constant of proportionality. Well, for it to be a proportional relationship, we said it has to go through the origin and be straight. So this is not proportional. Not proportional. Because it does not go through the origin. And because it's not proportional, we do not have to find the constant of proportionality. It says if it was to find it, and it is not. Number 11 is yours to do, so that gives me number 12. The points 0.5 and 1 over 10 and 7 and 1 2/5 are on a graph of a proportional relationship. That means we automatically know, because they told us that the graph does go through the origin and it is going to be straight. What is the constant of proportionality? Well, let's go ahead and graph this. If we had 5.5 and 1 over 10, we realize that we're always putting y over x, and this is in the form of xy. So the first thing we have to do is put both of these as decimals. All right, so if I'm going to put both of these as decimals, I would say that, well, this is going to be 0.5, but 10 would be 1 divided by 10, right? And we'll put that in a calculator so you can see exactly how that turns out. 1 divided by 10 equals 0.1. So now we've got 0.1 or 0.5 and 0.1 is our x and y. Since we put y over x, that means we have 0.1 over 0.5. And so what will our constant of proportionality be? Well, once again, using our calculator, if we take 0.1 and we divide it by 0.5, we get 0.2. So our constant of proportionality is 0.2. If we were to go ahead and put this as a fraction, we remember that any decimal number, we can go ahead and put a line under it and put a 0 with the 1 in front, and that would make this equivalent to 2 over 10, which equals 1 over 5. All right, so now we're going to do 7 and 1 2/5. All right, because we need 2 of them to show a constant of proportionality. But before we move on, let's remember this constant of proportionality we found was 0.2. Now, if we did this one, we would have 1 2/5 over 7. Well, we got to turn this into an improper fraction. 5 times 1 is 5. 5 plus 2 is 7. So this is really 7 over 5 divided by 7. And if we do this, we can use KCF because we have a fraction in a fraction. It's going to turn this to 7 over 5. We keep the first one the same. We change from division to multiplication, and we flip the next one. So if this is 7 over 1, this becomes 1 over 7. We're going to get rid of our 7, use the butterfly method, and we get 1/5. You might be thinking, well, that's not 0.2, but remember, 0.2 turns to 2 over 10, which is 1/5. So if I put my calculator to use once again, I would see that I would get 1 divided by 5, and that's going to give me 0.2 again. That means my constant of proportionality is 0.2. Let's see, name one more point on the graph besides this. Well, the great thing is we can always go ahead and find any other point by using our constant of proportionality. Our rise over run is 1 over 5. So let's see. If we had a graph, we could use, well, remember, 1 stands for y, and 5 stands for x. If you really wanted to get down to the nitty-gritty, you could say that I could use 1 and 5. Oh, I'm sorry, that's 5 and 1. I have to put them in the right order. 5 and 1. And that's going to go ahead and give me another point on the graph. If I went over, it would be 1, 2, 3, 4, 1, 2, 3, 4, and 5, and then 1. So that would be another point right there on the graph that that line would have to go through. Okay. All right. Let's see, over here we got write an equation that represents the proportional relationship. Remember, the equation we always use is y equals kx. And k is always equal to y over x, which means we can write the equation y is equal to 0.2 x. All right? And number 13 was yours to do. Looks like I'm all finished with the day. Good luck with the rest of your homework. Have a great night.